Okay, thank you. It's great to come back again this year and hear some good presentations, some very knowledgeable people. So I'm here to discuss the opportunities we have for alternative solutions, fuels in the off-highway market, particularly in agriculture. So first of all, I wanted to check if we've got any early adopters in the room. I don't know if anybody turned up in a natural gas powered tractor today. Fabrizio? Not even the organisers?
Really?
So, we've got some work to do. But although, if you took a bus, there was probably a 50% chance it was either a hybrid or alternative fuels, as 50% of the inner city fleet in North America is now powered by those means. I'm going to run through the history of FPT and its natural gas development in heavy-duty engines, and also some of the applications based on our CNH industrial product. Firstly, I'd like to make the customary showcase of our product and to discuss the various segments that we operate in. These are our 5 key segments as CNH Industrial, and we operate in all 4 regions: NAFTA, EMEA, APAC, and LATAM. We have the construction equipment here. It's showing a skid steer loader and a crawler excavator, but you can add wheel loaders, dozers, graders onto that list. And they're some of the most harsh environments, either altitude or dust and contamination, or even just operation cycles. Agriculture, these are our 2 main brands here, Case and New Holland. The Magnum tractor shown there, the red one, that's probably a familiar sight in North America. And then New Holland is our brand leader for clean power and innovation. Both brands make obviously a full range of agricultural equipment. Buses and trucks, these aren't probably quite so familiar for people based here in North America, but Europeans will see a lot of Iveco or CNH product out on the roads. Again, moving across the other regions, they're also manufactured in Argentina, for example. And then specialist equipment, based loosely around some of the other products, some of the other drivetrains, or should we say shared parts on the industrial side. But military equipment and firefighting equipment are another strength. In the middle there, you see engines and transmissions. Now this is where the FPT connection comes in. FPT is the brand that looks after the powertrain segment, and this is the common link between all the products that you see there. Now, along with a number of vehicle awards and Vehicle of the Year awards, there are 2 relevant and recent engine awards I can highlight. Our Cursor 16-litre engine, SCR only, took Engine of the Year award from Diesel magazine, OEM off-highway magazine, sorry. And then our Cursor 9 natural gas engine that we've recently launched took a Green Innovation Award over in China. So this is the timeline that the natural gas engines have followed within our business. We started in the mid-90s on a methodology that carries through till today, moving knowledge from Fiat passenger vehicles into the heavy-duty sector. The first engines hit the market in 1997. You can see we concentrated on a 2.8 litre, which is quite a light-duty engine. You'd see it in delivery vans or minibuses. And then also the 9 litre or 9.5 litre at the bottom there that lended itself to inner city buses, where pollution is obviously a concern. The next development happened 10 years later on. You can see there's the F1, there's an F and a Cursor. Anyone familiar with our lineup, they're familiar nameplates, and they're still being produced today. You can see here that advances in controls and materials have allowed a large increase for the 3-litre F1. You can see peak torque has gone up from 220 to 350 Newton meters. That really broadens the applications that this engine can go into and the drivability in machines. Most recently, as on the previous slide, there's the new Cursor 9 engine here at the bottom, manufactured at our plant in China and to be sold worldwide. Now this engine is very competitive in terms of power and torque output to the diesel engine on which it is based. The diesel engine, we have 305 kilowatts. You can see here we're nearly up to 300 kilowatts with the natural gas engine. At the bottom, a few statistics. FPT has delivered nearly 30,000 natural gas engines in heavy-duty applications, and currently in Europe we have 30% of the market. This, for anybody from Europe, mainland Europe at least, pays out in the automotive sector as well. Nearly every other Fiat you see, or every second Fiat you see at least, has a natural power sticker on the back, which means it's a factory-fitted CNG system in that car. So when we started with the natural gas engines, there were three main technologies. You can see the dual fuel, where we can run on both alternative and conventional fuels. What we call the stoichiometric technology, where we aim to burn all the fuel and all the air in the combustion process, and lean burn, where the fuel is burnt in an excess of air. Comparing these three with the Euro standards, back in 2008, the Euro 5, we had a number of competitors using different technologies, and they were practical for that emissions level. 2013, moving towards Euro 6, dual fuel has virtually disappeared, partially due to the fact that the compromises or the aftermarket aspect of it has been eliminated by improved sole natural gas product. Lean burn, it's feasible to meet Euro 6, but you do need to package and supply after treatment, which then pushes the costs or the installation problems up to that of a diesel engine. So we believe in FPT, for our applications, choosing the stoichiometric technology, that we're able to meet all the emissions requirements, and moving forwards we will continue with this technology and build on the experience that we've had over the last 20 years. So, key to the application of an engine, we need to look at the characteristics of the natural gas engine. Here, on our engines, we have no hardware change between compressed natural gas or liquefied natural gas. The engines are 100% compatible with biomaterials. This is particularly important for end users that we're promoting to in agriculture, who may be able to generate a certain amount of their own biofuel, but may need to supplement it with conventional fossil fuels. We have the luxury to compare same engine platforms in the same products to ensure that we have comparable performance. The after treatment that we'll be using is far more simple, easier to package. We don't have any DEF system, no pumps, no pipes, and also no DPF, so no temperature concerns or regeneration events. We calibrate to obviously the ISO standard for gas, but again, this can be altered or modified for particular end users in certain regions or certain applications. Number 6, the fuel cost. We know the fuel cost is reduced, and we'll go through that in the next few slides. Better control and materials, again, has given us a better transient response. This is quite important on applications that require improved cycle times. Reduced noise, less diesel knock. Again, quite an important criteria if we're looking at machines that are small and the operator's operating very close to an engine, working at rated power, or it's working in the proximity of people or livestock. And another feature that we worked on was to improve the quality of the materials, the cylinder head, the turbocharger, the manifolds. As we increase the power, we've had to dissipate and manage the thermal loads generated. So can these alternatives or natural gas be an option for agricultural applications? We've had the main characteristics, but now we need to check the basics of highway. If we look at the list here, we know the ATS is far more simple. It's easier to package. It's also far cheaper, reducing the purchase price of the machine, maintaining margin for the sales team, but also core reliability. If you are operating in harsh conditions, you could be right at the very limits of the technology that's being applied, and this extra or simplification would be a benefit to ensure that you can continue to work. The packaging, the diesel tanks, you can't beat a diesel tank. It's low pressure, it's very cheap to manufacture, it can be shaped to fit your application. And of course, if we go all the way back, a farmer can fill it with a bucket and a funnel, and lots regularly do. So, benefit for diesel there. Costs, we know, again, the natural gas is cheaper, pump price at the moment, and equally, given the benefits that we can use to burn biomethane, biopropane in these engines, the end user can actually make this material himself, so reducing costs even further. The final one is one that we're most concerned about, or were most concerned about. It's difficult to package the gas on the vehicle, partially due to the fact that the fuel tanks, the diesel fuel tanks, can be molded around transmissions, molded around hydraulic components, and balanced on either side of the machine. So at the moment, where packaging on space is a limitation, we have roughly half the autonomy of a diesel machine. Okay, so why did we choose natural gas? Two main reasons. The first one is environmental sustainability. And you can see a list here of the various gases where we will see a benefit or operations. Now, one of those main benefits is the what we call the CO2 challenge. And this is basically reducing our output of carbon dioxide while maintaining productivity or lifestyle or economy. Now, there's been quite a lot of press recently about passing what is referred to as the carbon tipping point. I guess everybody's read quite a bit about that. Just about every news website has been publishing various stories. This is passing a minimum of 400 ppm of carbon dioxide in the atmosphere over a 12-month period. Whichever side of that argument you're on, I guess, if it's permanent, if it's recoverable, if it can really be represented by a glass of wine being knocked over, I guess you'll agree, any effort to combat this must be a good thing for health, agriculture, and any of the systems that are affected by this. On the screen you can see the various fuels, fossil on the top, renewable on the bottom. Moving through, solid doesn't really lend itself to motive power anymore. There are certainly better alternatives. Liquid, within the fossil fuels, you can recognize some of the ones we've got there, what we call more conventional fuels, the diesel, the gasoline. In renewable we have bio-oil derivatives. And then moving across to the far side, we have what we're calling the alternatives. Let's say LPG or propane, ethanol, and natural gas. If I add this overlay, this will really show how we're trying to achieve the goal of reducing that CO2 output. We have to target the fuels with a higher hydrogen to carbon ratio, and these are the fuels that are over the far right-hand side of the table there, what we already labelled as the alternatives. Let's see the benefits that this will give to the end user. So going back to our Cursor 9 engine, where we are able to make a direct comparison between diesel and natural gas, and also comparing it to the EU limits on 3 well-defined emissions measures, which, although we're relating to EU, we know that these are the same measures used across many regions. Firstly, with natural gas, you can see we have a 14% reduction in the carbon dioxide on basically a like-for-like engine on a like-for-like cycle. Secondly, PM all but disappears. And thirdly, we have a large reduction in NOx. Now that is over and above the Euro 6 diesel engine, which is already meeting some fairly stringent requirements now, especially compared to a few years ago. Importantly, this discussion is based around natural gas derived from fossil fuels. We put a little oil rig there to show that. If we move to biogas, the carbon dioxide reduction is 100%. So this is the gas that the farmer can make himself on site, given the right equipment. Okay, the second driver for choice: reduction in total cost of ownership and/or running costs. Now this is something that the end user will see immediately, straight in his pocket. He's spending less money. Considering a pump cost difference of 20 to 25% lower for the methane or natural gas versus diesel, we have to take into account the different energy value of the fuel. We have to look at engine efficiency when burning these fuels. We would expect to realize a 15 to 20% reduction in that farmer's running cost of that machine. The prices are taken from across a number of European nations, but it's all relative between the diesel and the methane. Now, I spoke earlier just briefly about the biomethane, the farmer's producing his own gas. This is what CNH is promoting as an energy-independent farm. And here you can see that the savings are even larger, up to 20% higher than if he was purchasing the fuel. So this pushes us up to nearly 40% savings here. So on a mid-size tractor, or mid-size European tractor at least, doing 1,500 hours a year, the farmer could look to saving about 13,000 euros on his annual fuel bill. So how can he achieve this? Well, it's not for free. He needs a biomass plant. In the middle of this energy-independent farm, the biomass plant can take biomass from the fields, the waste crop, the chaff, the straw, whatever's left, the stalks. It can take agricultural manure, and it can take food and industry waste as well. Out of this plant, we would expect to get heat and electrical generation for the farmers' on-site facilities or for distribution. The waste can be used as fertilizer back on the crops to make the next year's batch of fuel. And of course, the biogas comes out. Some countries, this can be distributed on a methane grid, and obviously for everybody, he can take that fuel and run it straight into his natural gas-powered machine. On the right, you can see our number 2 prototype. This is a methane-powered machine. You can see it's a relatively futuristic-looking tractor, or as futuristic-looking as they get. And we can look into the application of the engine on this particular machine. First of all, what everyone's interested in. Other than the purchase price, how much power has it got? How much work can it do? I don't really need to explain these power curves. You can see that they're comparable. In the working range of the machine, the right-hand side of the graphic, above peak torque. We do start to see the power and torque drop off slightly for the natural gas engine below around 1200 RPM on that chart. This isn't an operating band for the machine, particularly if you've got a power shift transmission, and if you've got a CVT transmission that would allow the engine to throttle back in light load conditions. We can tune the transmission to ensure that we stay at that peak torque area where we also have the efficiency. Another big part of choosing the natural gas tractor or developing the natural gas tractor, as we've said, is this simple after-treatment system. Over on the right-hand side, you can see our Tier 4 final solution that we are selling in machines today. On top of the engine, you've got a DOC. Next to the engine, you've got the SCR and the cleanup catalysts. You've got, on the left-hand side, or what is the right, here, you've got a DEF tank, a DEF pump, a DEF injector in the DOC, DEF pipes, heating systems for those components. This is a similar hardware to what we'll be promoting for Stage 5 in Europe as well, with the addition of an on-filter solution within the SCR. So that picture will stay unchanged for diesel engines. Here on the right-hand side, you can see the scale difference in terms of complexity. There's no DEF, no DPF, no SCR, no DOC. It's just a simple catalyst within the exhaust line. Now, I don't know how clear that picture is blowing up, but this was our main concern, the autonomy challenge. How do we package these canisters, these high-pressure methane tanks? And that's where some of this futuristic styling came into play. We were able to hide tanks at the back of the cabin, under the wings or the body-coloured panels. Some tanks were able to be packaged where the conventional fuel tanks were. Obviously, they couldn't have the same capacity as the diesel tanks because they had to maintain the cylinder strength. So this machine has approximately half the operating time of the conventional diesel machine. Now, our diesel machines are sized to work at their planned duty cycle for one working day, up to 12 hours on a farm. Just to prove that it does work, we sized this tractor sufficiently so it could be used on a number of applications, particularly in Europe, where these machines could be seen doing field work. They could be used for stockman work, taking bales out to cattle, towing tanks full of manure, and planting crops. This machine is continuing to run in Germany. Now, the focus so far has been on methane, its availability, slightly Eurocentric maybe. In Europe, they have some infrastructure developments that aids this. There is a methane grid in some countries, and some of these nations are also subsidizing the build of biogas plants on farms. This is a massive draw for a fuel source if someone's going to pay you to build the plant to give you the ability to make your own fuel. But here in the US, maybe we need to look at alternatives. The infrastructure is slightly different, as are the natural resources. So if we consider the table a few slides back, we want to stay as far over the right-hand side as possible to keep our hydrogen and carbon ratio high. And here in the US, LPG would satisfy that requirement. I believe last year, I think we were a net exporter. So there's certainly capacity. The tractor you see here is our third alternative fuel demonstrator and the first one running on LPG. It's also a far more conventional looking machine and was shown this year at the Farm Progress Show here in Iowa in August. We've since sent it back to New Holland's base and it's taken part in customer clinics with key customers, targeted end users and also suppliers of applications or components for these machines, which we'll go into. And the feedback was pretty good. It drove like a diesel, just like a normal tractor, quieter in the cabin. So pretty good considering these people are the people that spend most of their time using conventional diesel machines. And again, here we're predicting a 20 to 40% saving on fuel versus a conventional diesel tractor. As we saw before, in terms of the fuel packaging, just a quick slide here to show how we've achieved it. There are different shaped tanks. There's a number of different tanks here, but they're all mounted low down in the machine. This is why we've managed not to have to add extra fairings, extra covers. Now, with the LPG, this has given us the ability to package for approximately 50 to 80% of the autonomy. The closer we can get to that full working day, obviously the better it is for the end users. Okay, our market opportunities. We've had interest from various areas in these LPG powered tractors as the diesels become more complex, more expensive, maybe even slightly less reliable due to the number of sensors and parts within the after treatment system that can cause trouble in these off-highway applications. The key customers that we're targeting here are highway mowing agencies and government agencies that are looking to utilize clean energy, farms and industries that already have LPG or propane or methane on site. And also we've got a lot of interest from equipment manufacturers trying to make customized product for those end users. Not having the SCR, not having the fuel tank or the DEF tank mounted in the middle of this machine gives them a lot more flexibility in being able to mount mowing equipment, mid-mounted mowing equipment that increases visibility for the operator and reduces the opportunity for accidents due to an unbalanced tractor. Other markets as well, you can see in Europe, particularly Germany, there's a big demand, and APAC, Russia, there's also some interest in LPG machines. So in summary, FPT has been developing, it's been a leader in alternative fuels for 20 years in the heavy duty sector. The number of sales signifies that we're successful there. Natural gas engines certainly reduce greenhouse gas and reduce emissions compared to diesel. Operating costs, we've proven with our machines that can be significantly reduced, let's say 20% at a minimum. The tractors are capable in the field, we've got them working, we've got end user feedback, and we have tested them back to back. And for most of the applications of these machines, they're not high draft machines, they're not there working, slogging away in a field 12, 15 hours a day. the limited autonomy is not noticeable to most of these users. So we believe that natural gas does have a market in the off-highway and the agricultural industry, and we already have the technology to satisfy that. Thank you.